is a competitive examination taken by millions of students every year in India. This is from the Computer Science Information Technology paper. It's a question on the theory of computation. Here's the problem, paper 1, question 42. It's a seemingly pompous question, but it can be made simple by a trick. We use regular expressions, and the trick is this pompous question can be made simple by the use of regular expressions. Here's the problem, question 42. There are two context-free grammars, G1 and G2. We are supposed to find out which one of the pairs of languages given here is generated by G1 and G2. We are told G1 and G2 are context-free grammars. Let's verify. In G1, the left-hand sides of the rules are S and B, non-terminals. In G2, the left-hand side of the rules are S, A, and B, non-terminals. So both are context-free grammars. It's a multiple choice question. The examiner guarantees 3 answers are wrong and 1 answer is correct. If we can guess the wrong answers, what is left is the right answer. So let us start by considering each one of the choices one by one. Let us first consider grammar G1. What does G1 generate? G1, for example, these are the 2 rules. This rule S is a recursive non-terminal. So S generates A plus S depending on how many times I use it. Then S goes to B. B generates B plus. So this generates the language A star B plus. But I need not use this rule. So I will have, for example, S going to B and B plus alone will come. Or it can be preceded by A's, as many A's as we want. So it's going to be this language A star B plus. So consider choice A. The choice is M must be at least 1 or more, or N must be 1 or more. The above can be said M can be anything and N can be anything. The trick is the OR operator. So this includes the string just A, and this is not going to be in the language generated by G1. For B is compulsorily in G1, A cannot be just 1. Because B has compulsorily got to be there. So this choice is out. It's a false choice. Consider choice B. The language generated by this can be written as A plus B plus. M is greater than 1 and N is greater than 0. So A, B must both be compulsorily present. So we have A plus, B plus. It is not A star B plus. So it's not what G1 generates. This is a false choice. Let's consider choice C. Here we have an OR. It allows N to be anything. So the empty string is in the language. So language generated by the grammar. So this choice also is out. So the empty string is not there in G1. G1 is A star B plus. In other words, we are going to have at least 1 B in G1. This we have a choice of just having epsilon. So choice C is not valid. By elimination, the answer must be D. So we will not even look at what D2 does. So we discussed that choices A, B, and C are false. We rely upon the examiner to take the trouble of saying 1 answer is correct and 3 are wrong. This is a trick we use in multiple choice examinations. It is formalized by what is called the IP equals P space theorem in computational complexity. The examiner takes a great deal of effort to set the question, that's in P space. But to solve it as a multiple choice question is only of polynomial complexity. It is called the IP equals P space theorem in computational complexity. It sort of collapses all these multiple choice questions. Anyway, let us verify choice D. Here we have A to the M, B to the N, M greater than or equal to 0, and N greater than 0. That is, M can be 0. So we have A star B plus. To compulsorily we'll have 1 or more B's B plus, 0 or more A's A star B plus. This is a language generated by G1. So this indicates our choice that G may be correct. So in our case, we did not consider the existence of D2. For our satisfaction, now let us verify what D2 does. G2, here is the language. B generates what? B star, 0 or more B's. Then we have got what A generates. This says A star and then followed by B star. So A generates A star or it generates B star. The case of D2. Here in this case of D2, what does D2 generate? This generates A star, this generates B star. So language generated therefore is A star, B star minus epsilon. Epsilon is not there in the language generated by it. Because we are compulsorily going to have at least one A or one B. Now choice D is revisited. Let's consider choice D. In choice D, we are considering what D2 generates. This says M must be greater than 0, one or more A's, followed any number of B's, or any number of A's followed one or more B's. There's going to be A star, B star minus epsilon. Epsilon is not allowed. Any number of A's followed by any number of B's without both being 0. So it's a language generated by D2. So D is going to be the correct choice. So we have both guessed and verified that D is the answer. The answer, therefore, is choice D. End of the presentation. Thank you for your attention.